symmetry by me. Reflection symmetry. Reflection symmetry is shown by what we call lines of symmetry. Here are some facts about lines of symmetry. Lines of symmetry separate a figure into two parts of equal size. They don't need to be vertical, they can be diagonal, horizontal, etc. And a figure can have several lines of symmetry, seen in the circle. See how it has a horizontal, a vertical, and two diagonals. Cutting it into multiple pieces, but each line of symmetry cuts the circle into two parts. Okay. Here is a figure that has multiple lines of symmetry. First, I drew a 4" by 4" square, and I needed to find the middle, or basically cut the square in half. So first, I folded it this way, then I folded it this way, and that cut the square into two halves, allowing me to find the center point. Another lines of symmetry can go diagonally, this way and this way, mirroring the square on both sides. You can also see that when you fold the square in half, diagonally, triangles are formed. Two identical triangles, seen here and mirrored on the other side as well. You can see many triangles are actually formed, but regarding mirroring and cutting in half using these vertical and horizontal and diagonal lines, you can see that two triangles were formed here. And when you fold it in half, two rectangles were formed. Let's get a different color. That helps. In purple, you'll see the two rectangles formed. And this is the same for the vertical line of symmetry down the middle. Here's another one. So the square has a lot of shapes inside of it, and they are found by using lines of symmetry. This is an example of a shape that has a single line of symmetry due to its odd shape. If we fold this one in half this way, we can see that they perfectly overlap each other, making this shape a mirror on this side, just the opposite. So when you open it up, it's a double on this side and this side. Now, if this figure only has one line of symmetry, because if we tried to fold it this way, they don't line up. See? Up here. So this figure only has one line of symmetry. Now if we tried to do diagonally, again we'd run into the same problem of the figure not lining up. So once again, this figure only has one line of symmetry. Rotational symmetry. Rotational symmetry facts, or the definition of rotational symmetry. A figure has rotational symmetry of order n if there is some center point P so that a rotation with a center P by 1/n of a turn carries the figure onto itself. And I'll show you an example because this definition is quite complicated, but it's actually quite simple once it's explained with a figure. So here we have a figure, once again our square of 4 inches by 4 inches, and we have this figure with center P as mentioned in the definition. So in order to explain what rotational symmetry is, I created a replica of this square with a clear kind of transparent version. So I'm going to place it over the original square, still seeing center P. So it's showing that a figure has rotational symmetry of order n, n being 4, because this figure can be turned 4 times. Notice that the green is in the top right. 1, 2, 3, 4 times to get back to its original spot where the green is in the top right. So it is also saying if there is some center point P so that a rotation with the center P by 1 over n, which would be 1/4 of a turn, carries the figure onto itself. So if I did 1 turn, although it's not exactly the same as it was originally, this square is still covering this square and it's the same shape. It carries the figure onto itself. So this is an example of what rotational symmetry is. So now we know that this figure, what I just explained, is rotational, but it is also reflective in symmetry because I use the exact same figure in both explanations. Some figures are just reflectional and some are just rotational, but in this case, it's both. Thanks for watching!